All right, so there are a lot of different databases out there. You may have heard about MySQL, SQLite, Postgres, MS SQL, Cassandra, MongoDB, Redis, Memcache. They're all source of database. So I'm going to try to help you explain how all of these kind of fit together before we zoom in into a specific SQL database and give you some perspectives on the overall landscape. So first of all, why are there so many different databases out there? Well, you can imagine if you refer back to the IKEA store analogy, and you had millions and millions of different parts to store at a warehouse. If I had 10 people go and design the most perfect ways to store those millions of different inventory parts, and if I ask them, go in and design the most effective, efficient way to store these parts, they're all gonna come back with different opinions and philosophies or processes on how to store data. So that's basically, how you can think about why there are so many different databases out there. No one thinks exactly the same thought. They all have different opinions. And plus, it depends on the objective, right? Maybe someone goes and designs a database and they really optimize for fast retrieval of data. Maybe someone else goes and design a database that's really optimized for making sure that the data that comes back is very reliable and is optimized for updating and deleting and making changes. So it's optimized for that rather than optimized for selecting information or retrieving information. So anyway, you can see depending on the objective, depending on how big the data that you're holding, you can have different design criteria. For example, if I say go in and create a warehouse for storing 1,000 different inventories versus I tell you go in and create now for storing 10 million inventories versus let's say 10 billion inventories, right? Depending on the criteria that you're optimizing the database for, you come up with a different, design. Okay, and again, that's why there are so many different databases out there. All of them are storing data, but you could look at this and kind of categorize different databases into a few different buckets. So one of the bucket that you can divide these databases is by looking at, okay, are you storing the data on memory or are you storing the data on a hard drive? Okay, all right, so if you take a given computer, and I hope you know what the difference between a RAM and a hard drive is. RAM is basically memory, so if you restart the computer, if the information is stored in RAM, it just goes away because it gets reset. But if you store things on a hard drive, even if you restart the computer, it remains, right? So, and there's a term for that, but I'm not going to go into the terms yet, okay? So if you store things in memory, for example, if maybe the computer comes with, let's say, 2 terabytes of hard drive and 32 gigabytes of RAM, okay? Usually the amount of RAM is significantly smaller than the amount of disk space available on a hard drive, okay? Now, if the database is stored in RAM, what is the benefit? It's extremely fast. Thousands of times faster than storing information on a disk. Okay, what's the downside? So it's very fast to store and retrieve, thousands of times faster than database that stores information on a disk. But what's the downside of storing that on a memory? The downside is if the computer power runs out and the computer restarts, you lose everything. Okay, so for example, Memcache, Redis, and some of the memory-driven database, you can use this to store short-term information that even if the power goes out, there's a power outage and the computer restarts, you don't care if you lose the data. You can store those into Redis or Memcache. So some good examples of that is a lot of real-time data, like sending a real-time chat, and maybe you don't need to store a history of the chat, you just want to display it, and then you don't care if you want to remember that information. Those type of things you could store into memory. It's extremely fast. But if you ever need the computer to remember after the computer restarts, then you have to store on disk. Okay. Another downside of storing things on a memory is you can only store usually significantly less information than storing things on a hard drive. Okay. Now, so this drive storing most of the databases store information on a hard drive. So MySQL, Postgres, Oracle, Hadoop, and some of these other things are all things that store information on a hard drive. The downside is slower than storing information on memory, but still it's not really slow. You can still retrieve records amazingly fast. And you will have a feel of that as you write SQL queries and learn how fast the computer can sort through thousands, tens of thousands, hundreds of thousands of data, maybe even millions of data, and how within a second or less, it can actually sort through all of that information and spit out specific results. You will be surprised how fast even this drive is. But memory is thousands of times faster. Okay, so have that in mind. Another difference is one system versus distributed system. So if you get a computer, let's say it comes with 3 terabytes of hard drive. Well, how big of a database can you build with a single computer that has 3 terabytes? Well, the maximum is probably going to be like a little bit under that 3 terabytes because the computer also needs to have an operating system, other programs run. So the database that can be created in that single computer is probably, a little bit less than that 3 terabytes. Okay, so the size of the database is usually dependent on, well, how big of a hard drive does a computer have now, right? If you're deploying application in the cloud, they will tell you, oh, if you pay us this much a month, we'll give you a hard drive space of this much and this much and that much. And that will basically dictate, if you have a single database, how much data you can hold. Now, intuitively, you may not have built a sense yet on how big of a data how big some of the data are. So let's do some exercise here. So imagine you want to store all the business information for every single business in the world. Okay, so let's just come up with a guess. Maybe that's 1 billion businesses, and you want to store their address, the business name, the phone number, the website, and what the categories that the business is in, and what country they're in, and all of that. So you want to store that in a database. How much disk space do you think you would need to organize that? And of course, it depends, right, on a few things. But as a rule of thumb, is that going to be 1 megabyte, 10 megabyte, 100 megabyte, 1 gigabyte, 10 gigabyte, 100 gigabyte, 1 terabyte? Okay, well, I do have a data point on this because one of my first startup was building something like Yellow Pages for US businesses, where I had millions of businesses and I stored that in a database. Now, that size of that, I would say, is probably in the order of 1 gigabyte of data or less than that. I would even argue that you may even be able to get it down to about 100 megabytes of data. Okay, so you can have a single database handle lots and lots of information, even in a single computer. Okay, so now let's go into this. So let's say my database becomes so big that a single computer just cannot handle it. There are databases designed to handle large amounts of data, and that's often called big data. So for example, when you get into Hadoop, that's leveraging a lot of small computers, and it's basically distributing the workload. So there's a central computer and a unit that is given a task, and they basically delegate to a bunch of these little computers. Little computers do the work, find the data, and then they bring it back to the computer that manages it and spits it out. So that's kind of what the big data are. So as a rule of thumb, right, you just look at a computer now, or you look at the cloud and says, what does a typical cloud package come in terms of the hard drive? And that's basically how big a single database can usually get. I'll explain an exception. If you need a lot more than that, then you want to go into Oracle. But it's very, very expensive. But Oracle can support large amounts of data. But let's say Oracle can't, you're dealing with tons and tons of data that even Oracle cannot handle. Let's say thousands of times more data than what a single hard drive can handle. At that point, you may consider big data, such as Hadoop and other places out there. Okay, so anyway, those are some of the ways that you can look into memory versus disk, one system versus distributed system. Now, having said that you could, let's say, hold 3 terabytes of information on a single computer. Does that mean if you're using MySQL or Postgres, you can only hold 3 terabytes of information? No, it doesn't mean that, because you can shard it. For example, you can say, I'm going to have one warehouse that's going to have 3 terabytes of information, and that only stores information about bikes. I'm going to have another warehouse that's going to store information about cars, airplanes, and another one. So you can basically, this is called sharding. You shard the data, you break the data, and you store one part of the data into this warehouse, another part of data into this database, and different databases, and you can set up another program that says, okay, why don't you be the coordinator? So if someone asks for the information, you'd find out whether the information is stored in this warehouse or at this one, and you coordinate that. So even if you're using Postgres or MySQL or Cassandra or others, you can still handle lots and lots of data. And again, if you're not familiar with how to scale the database, you can read my article, which I'll provide below. And you can see how you can really scale the database beautifully. Another way to look at the database is you can also host it yourself, or you can just leverage the cloud and install the database directly in the cloud. Now there are all these services offered by major cloud providers where they will actually do all the management for you. So there are all the different options. Now there's another one that I would mention when you look into the database. There's this concept of a relational database and a non-relational database, a SQL database or a NoSQL database. Now, for you to fully understand what the differences are, I think it's a little bit early. So what we're going to have you do is just get familiar with the SQL and relational, where you're going to have multiple tables. And you will know what I mean as you go and do the exercises. And later, after you level up and you had more experience with SQL and database design, then let me introduce you what non-relational databases are, such as MongoDB, and explain when to use a non-relational database versus a relational one, and so forth. But for this course, we're going to focus more on specifically on SQL, especially MySQL.